Number 10. The scatter plot shows the relationship between two variables x and y. Which of the following equation is the most appropriate linear model for the data shown? So we have four linear models, all in slope-intercept form. For this type of question, the first step we take is to draw the line of best fit that best models the data given here. So it's something like this. First thing to note is that this line has a negative slope. So I'm going to eliminate all choices with a positive slope. So positive here. So eliminate C, eliminate A. So which one is the right choice, B or C? So we have to check the y-intercept. Y-intercept is where our line cuts the y-axis. So it's somewhere between 9 and 10. So looking at choices B and C, we see that the y-intercept is either 0.9 or 9.4. So clearly this point is much closer to the actual y-intercept here. So of the line of best fit. So our choice is D. Number 11. 2.5b plus 5r equals 18. Given equation describes the relationship between the number of birds b and the number of reptiles R that can be cared for at a pet care business on a given day. If the business cares for 16 reptiles on a given day, how many birds can it care on this day? So it's a linear equation with two variables, no? All we have to do is, because we are given r equals 16, we just need to plug that value into this equation and solve for b. So 5 times 16, that makes 80. Now subtract 80 from both sides. So that's going to mean this disappears, this term, minus 80 equals 0. So 2.5b equals 0. Dividing both sides of the equation by 2.5, we get b equals 0. So they care basically for no birds. So the answer is A equals 0. The next one, question 12. So we are given the graph of a linear equation here, no? A line, and they're asking us which equation is the graph shown. Okay, so this line has a negative slope, no? So of the choices, we are going to eliminate the choices with positive slope. Slope is the coefficient in front of the x term, no? So here is negative. I keep this. This is positive slope. I eliminate this. Keep this. Positive slope, eliminate this. So the answer is either A or C. So their y-intercepts are the same. Slopes differ. So what is the slope of this line? I'm going to use rise over run definition for the slope. I start from here, this point, and starting from here, how do I come to this point? I go up, rise up. Because it's up, it's plus 8. And then I move to the left. Because I move to the left, run is negative. Because I'm moving left, so it's negative 8. So 8 over negative 8, slope is negative 1. So it's this one, negative 1 slope. So our choice is C. Next question. 13. If x over 8 equals 5, what is the value of 8 over x? So we can just multiply both sides of the equation by 8. 5 times 8. And we can get x as 40. And then plug this value here, 8 over 40. Simplify it, 1 over 5. But there's a quicker solution, no? We know that x over 8 equals 5 is 5 over 1, no? If we actually take the reciprocal of the left side, taking reciprocal of a fraction is flipping the fraction, no? That means we are going to get 8 over x. What we are looking for, no? If I flip the left side of the equation, I have to flip the right side also. I have 5 over 1 on the right side. If I flip that, that gives me 1 over 5. 1 over 5 is our answer. So that's the quicker solution, whichever you prefer. Number 14. So we have two linear equations in this system of linear equations. And then they basically ask us the y value of the solution to this system. Okay, I'm going to move by actually eliminating y here. So, although we're trying to find y, no? So, let's say this is equation 1, this is equation 2. I'm going to subtract equation 2 from 1. Okay, so what do we get? 24x minus 6x is 18x. Y minus y is eliminated. We get minus 24. No? So we get 18x equals minus 24. Simplify, I'm going to divide both sides by 3. So we get 6x equals minus 8. Now I'm going to use the second equation. Second equation is 6x plus y equals 72. 6x, I found it to be minus 8. So I'm going to plug that value. Minus 8 plus y equals 72. Now I add 8 to both sides of the equation. We get 72 plus 8. That gives me y equals 80. So the y coordinate of the solution to the system is 80. We move to the next one. Number 15. Line T in the xy plane has a slope of negative 1 over 3. This is the slope and passes through this point, 9, 10. Which equation defines line T? So we are given the slope, which is this. So I'm going to eliminate any choice with a different slope. No? Slope 13, eliminate. Slope 9, eliminate. So the answer is either this or this. Which one? Well, I choose the right one by plugging this value. No? When I plug x value, 9 for the x value, it should give me 10. So if I plug in 9 here, 9 over 3 is negative 3. No? Negative 9 over 3, negative 3 plus 10. But that gives me 7. No, it doesn't give me 10. So I eliminate it. And I actually plug it here, 9 over 3, negative 3 plus 13. That actually does give me 10 as desired. So our answer is D. Next question. Number 16. Here's an exponential question, exponential model. Function f of x equals 206 times 1.034 to the x power models the value in dollars of a certain bank account by the end of each year from 1957 through 1972, where x is the number of years after 1957. Which of the following is the best interpretation of f of y? F of y is approximately equal to 243 in this context. Well, let's think about this. This gives us basically value in dollars in the bank. X is number of years after 1957. If I'm looking at f of 5 years after 1957, that means 1957 plus 5, that would give me 1962. I'm looking at year 1962. And if I plug 5 into this equation to find what f of y 5 is, that would give me, and then our coefficient is 206. When we actually plug these values into our calculator, that spits out, this exponential term is 1.182 times 206. When we multiply it, this does actually give us, when we round it, it does give us 243. So basically, the answer is B. The value of the bank account is estimated to be approximately $243 in 1962, as we just discussed. Number 17. For a certain rectangular region, the ratio of its length to its width is 35 over 10. Okay, that ratio is 3.5. If the width of the rectangular region increases by, so if I actually give these values now, let's set the length to be 35. If the length is 35, the width has to be 10, no? Because I'm trying to keep this ratio. 35 over 10. Now I'm changing this, no? If I'm changing the width by adding 7 units, I'm increasing it, 10 plus 7. So the question is, how much should I add to the length? No? Let's say x units to the length, such that this ratio is maintained. Length over width, what's the ratio? 3.5. Okay, so let's simplify this. We have 35 plus x equals 10 plus 7 is 17 equals 3.5. Now this is one equation in one unknown, no? The only unknown is x, what we are looking for, no? The amount we have to increase the length such that this ratio, length over width equals 3.5 is maintained. So if we actually solve this, I'm going to multiply both sides of the equation by 17. We get 35 plus x equals 3.5 times 17. If we do this, this is 59.5. Subtracting 35 from both sides of the equation, we get x equals 24.5. And that's exactly choice B. It must increase by 24.5 units. Number 18. Square P has a side length of x inches. Square Q has a perimeter 176 inches greater than the perimeter of square P. So square P, side length x, square Q, we don't know its side, but we know its perimeter. So perimeter of square P is 4x. Perimeter of square Q in that case is 4x plus 176. They ask us, the function f gives the area of square Q. Well, the area is side squared. So if this is the perimeter of square Q, to find its side, you would need to divide its perimeter by 4. That would give, let's simplify it, 4x over 4x plus 176 over 4 is 44. What is this? This is the side of square Q. If this is the side, its area would be x plus 44 squared. Looking at the choices, this is choice A, and we are done.